Lesson 8.6, Day 2, the very last lesson of Chapter 8. We're going to solve equations with logarithms. And look here at the top box of our notes. I've highlighted the three properties of logarithms that we have been using all along since section 8.5. We were even using that exponent property, this third one right here in the list yesterday. But really we're going to solve equations that involve logs. Properties can be used to condense logs, and if they're given as an addition or a subtraction, we can combine them into just one logarithm. The top right portion right here, dare I say, we're really not going to see a lot of this in action today. However, the bottom two topics here are going to be very, very key. We have our properties that we worked with the other day, but here's something new that comes from common sense. If log base b of x is equal to log base b of y, then the arguments must be the same. I'm going to put a big star by there. Again, if you have a log equals a log with the same base, set their inside parts equal. This other one down here is our definition. If you have the log base b of u equals a number, not another logarithm, but set equal to a number, we can use the definition of the log. We were calling it the log circle, and we could rewrite the problem in that way. So what I've highlighted in green, very, very important, all of our problems will either eventually lead to a logarithm equaling a logarithm, in which case we set the inside parts equal, or a log equals a number, in which case we'll do a log circle. Also, we're going to have to check right here, since we can never take logs of negative numbers, we're going to have to make sure that our answers do not cause negatives to be inside of logs. If they do, we throw them out as an extraneous solution. So let's look at number one. Like I said, in this green highlighted section, either you have a log equals a log, in which case you set the insides equal, or you have a log equals a number, in which case you do a log circle. Well, look at the right hand side of number one. It's not a logarithm, it's just the number 2. So we are going to do a log circle. We're going to write 3 to the second power is equal to 2x minus 1. 3 to the second power is a 9. So we have 2x minus 1 equals 9. Very quickly we can add a 1 to both sides. 9 plus 1 is 10. And if 10 is equal to 2x, or if I rewrote that as 2x is equal to 10, divide by a 2, we'll have x equals 5. Now, this might seem fine, but honestly, we need to check one very huge question. If I were to plug that x equals 5 back into the original equation, I'm going to highlight that right here, rewrite that out, putting in your x value of 5, what your big concern is that inside part positive? Well, 2 times 5 is 10. 10 minus 1 is a 9. We would arrive at log base 3 of 9 equals 2. Most important, we see the inside, the argument is positive. We could double check with a log circle, but to be honest, as soon as we see this is positive, we know our answer of 5 works. So this is good. Take a look at number 2. Number 2, we had the properties of logs the other day, that if logs are added, you may combine them into one log by multiplying the inside parts. Very important property. And distributing this inside part, x times x is x squared, x times a minus 8 is a minus 8x. Well, now what? Well, we have to ask that very important question at the bottom of our box. Either we'll have 2 logs equal to each other, or a log equals a number. Well, look at the right hand side. It's simply the number 1. So what do we have to do? do a log circle. We will get 9 to the 1 power is equal to x squared minus 8x. And of course 9 to the 1 power is simply a 9. What now? Well, we need to get 0 on one side. Let me continue up here. Very important to remember how to solve a quadratic. If you're solving a quadratic, something with x squared, you need to get 0 on one side. We need to try to factor. Look, we can add up to -8, multiply to -9. There aren't too many ways to multiply to a 9, or a -9 for that matter. You need a 9 and you need a 1. And real quickly, if we're adding to something negative, the larger number must be a negative. So we'd have -9 multiplying to -9. Of course, we need a +1. Double check that we add up to a -8. We do. Take x minus 9, set it equal to 0. Take x plus 1, set it equal to 0. Minus a 1 from both sides here, you get x is -1. Add a 9 to both sides, here you get x is 9. Well, now what? Well, tell you what, we have to do a check. But very, very quickly, as we're doing a quick check, the most important thing is very simple. Do we have a positive number inside of the log if we use this x value? Let's see, we'd have the log base 9 of 9 plus the log base 9 of 9 minus 8. Well, do you know what? Look inside of your logs here. This is positive. 9 minus 8 is positive. This works. This works. It checks. Of course, we could go another step further to see. Let's do a check over here with -1. X equals -1. Go back to the original problem, but wherever we see an x, plug in -1. Hey, we're in trouble. Right now, we can see we don't even have to continue to go on. We can say, do you know what? We cannot count this answer. We have a negative inside of the log. We've got to check it out. It doesn't work. So please be careful. Probably the biggest mistake kids make is they forget not to check. One solution, x equals 9 here. Take a look at number 3 with me for a moment. Number 3, as you look to the left, you'll have the log base 3 combining these two into a division. You can have x divided by x minus 1. But here we go again. We have a log not equal to a number now, but a log equal to a log. Now here's the catch. If you have a log equal a log, the only way that's true, providing that we've got the same bases, is that the inside parts must be equal. So this is going to equal 2 all over 1. We can cross multiply real quickly. We get 1x is equal to 2 times x minus 1. This would be 2x minus 2. Well, we could continue. Let me recopy it up here. I'm going to subtract a 2x from both sides. 1x minus 2x is a -1x. Divide by -1, and you'll get x is equal to 2. But we should go through with a check. Write down the original problem and make sure that when you plug in a 2, you're actually getting all positives inside. You know what? We are. Of course, we could even go further, but as long as you see that you're getting positives inside here, this works. It's going to be good. Alright, let's take a look at number 4 real quickly. Sadly, we don't have a log equals a log like we just did. We have to do a log circle. 4 to the 1 is equal to x squared minus 3x. Tell you what, let's subtract a 4 from both sides. we'll have 0 is equal to x squared minus 3x minus 4. Factoring. Again, factoring for the sake of time right now. We only have like 5 minutes left or less for our video. We have x minus 4 times x plus 1. Obviously, we have to multiply to negative 4, add to negative 3. This combination would do it. Look, set x minus 4 equals 0. Take x plus 1 equals 0. Let's add a 4. You'd get x is equal to 4. Here you subtract a 1. You get x equals negative 1. Now please watch out. Very, very often kids will say, I get it. Negative 1 doesn't work. Well, be careful. Let's do a quick check. Log base 4, you'd have negative 1 squared minus 3 times negative 1 equals 1. Negative 1 squared is a 1. Negative 3 times negative 1 is a plus 3. Guys, the inside is positive. It's just going to be a 4. This works. It's going to be fine. You might guess that the other one's going to work also. By the way, it will, but you should check it. Just looking inside, 4 squared is a 16. And then 3 minus 4 is 12. Look at that. It works. 16 minus 12 is positive. 2 answers. A negative number might be a valid solution. Let's do number 5 real quickly. We've got log base 3 combining the 2 logs on the left. Using the property we've been using, we'll just add them together. And I'll distribute inside. We'll get log base 3 of x squared plus 3x. But again, no need for a log circle here. You have a log equals a log, and furthermore, you have to set the insides equal. This might look very familiar. It might even appear to be the last problem that we just did, but if you're really on your toes, you'll see it's different. You'll have x squared plus 3x minus 4 equals 0. Factoring, try x plus 4, x minus 1. And then double check. You're adding to a 3. You would with a 4x and a negative 1x. Multiplying 4 times negative 1 is negative 4. So take x plus 4, set it equal to 0. Take x minus 1, set it equal to 0. You'll get negative 4. So x equals negative 4. Add a 1 here. You'll get x is 1. The big question is, do both of these work? Well, you don't know until you do a check. Plug in negative 4, you can immediately see you're in trouble. Let me just say plus dot dot dot. This can't work. Sometimes kids are like, how do you know? Well, look, you're plugging in your x value. It's negative. No good. It's not going to work at all. As soon as the negative's inside of a log, you have to throw it out. Finally, let's check the 1. Just because one answer works doesn't mean that the other one doesn't, and vice versa. You have to individually check these. You can see that no matter what you're plugging in, you're going to get positive values. 1 plus 3 is positive, and a 1 is positive. So x equals 1 works. So definitely check your answers. Sometimes you'll get 2 answers that work. We saw that in the previous example. Very often, though, one of your answers will fail. We've also seen, like in the previous problem, that a negative answer can very well work. It's not a matter of whether the answer itself is negative. Rather, it's a matter of when I substitute that answer in, does the inside of the log stay positive? If it does, that answer works. Well, best of luck to you. This is now it for Chapter 8. We're going to have quite a bit of time to review, so hope that will help.